G'day. In this video I machine these. These are an angular fixture block. It's from a casting that I designed myself. And so I take you through the steps of doing this and in particular how to get the angles between the faces spot on, or pretty much spot on. There'll be another video later on detailing putting the holes and bits and pieces for the fixtures on there, but this one's long enough as it is. Hopefully it's of interest to people. Gives a few clues on setting up castings, as well as how castings are made and all that sort of things. To cast something like this you need a pattern, and this is the pattern for these parts. This is made out of wood, and the way these work is that you put a half in one side of the mould and half in the other side of the mould, pour molten metal in, and you get a casting. Now, a couple of things about castings. One is that if the designer has got their thinking caps on, you'll have a parallel side, because one of the characteristics of cast products is that they have a thing called draft on them, and the draft is purely so the pattern can come out of the mould. But typically you have 3 degrees or something like that, which means trying to clamp on that is going to be difficult. Okay. The other thing that you'll have is lots of radii. Usually the skin of these things is pretty tough. It's got sand mixed in with it. It's cooled the fastest, so it's approaching white iron. So once again, the designer of the casting should allow 3mm, 1/8 of an inch, something like that on there, to be machined off if you want a good machining surface. So a casting will come out of the sand with draft on it, a little bit oversized, few radii. Typically the foundry will dress it up a little bit, but basically it's up to you as the machinist to do your thing. Now these things, I need to clean up those 3 faces. I've already cleaned up the top face and the bottom face. I did that some time ago. So I'm going to show you how I do those, because there is a trick or two to this. But at the end of it, I'll have a couple of fixture blocks that will be very handy, I hope. These days patterns are just as likely to be 3D printed, but the old time pattern makers were very skilled people, because they'd do this in wood or metal, depending on what sort of wear this thing was going to need. But what the pattern makers would do, there's a certain amount of shrinkage you get on a pattern or on a casting, and so when they made their pattern up, they would allow for that shrinkage. Also, if you've got non-uniform sections, if you've got sticky out bits and all that sort of thing which are going to cool quicker, they might distort, and so the really skilled pattern makers could anticipate that in their head, and the pattern you've got may not look like the finished casting. You know, it might have a bit of a curve to it, but the idea being that once it came out of the mould and it did all the cooling the pattern maker thought it would cool into the finished shape, which was what the design called for. The first step here is to clean up the clamping faces, and as I said earlier, I've already done that. And that was basically a clamp going through here, clean up a bit of that, and then swap the clamps over, clean up the other side. Bit awkward, but it does the job. All you're after here is clean up to get a decent surface that you can use as a basis for your clamping. This is the main trick to machining off these faces. In a moment we're going to mount up a cutter. It's a carbide face cutter, bearing in mind that the recommended surface speed for grey cast iron is about half that of steel, so adjust your speeds down accordingly. But the way I'm going to do this is I've got an angle plate here and I've got my casting clamped, and I'm going to get that so it's level. Now, one of the things that you can use for setting things up is a level. This one's a convenient one for me, because it's got an adjustment arrangement so that I can actually level it on my bed. The bed here isn't precisely flat, and so what I'll do is I'll set this on the bed. I'll then set this up here, or if I can see that the web here is not terribly uniform, I might put a piece of material out there so I can make sure that that is parallel with the bed, and that means that when I machine this, I'm going to get this surface parallel to whatever surface I want. First pass made. I've had to put another angle plate on here and tie that all in to get things going, because it was just twisting a little bit as the cutter was hitting. Probably could have been expected, but I was hoping to get away with one. But that's all right. I do have a little bit of porosity here coming up in the casting. Now, I'm only doing the smallest cut I can just to get full clean up on here. And so that doesn't surprise me. I've still got, 2.5, 3 millimetres worth of good material to get off. But what I want to do is basically clean these all up all over and then bring them down to, a good size, good finish and all that sort of thing. So you will see that occasionally. Now, grey cast iron in particular is rather messy stuff, so I'd say have your vacuum cleaner around the place to take up chips. I've also put some barrier cream on to try and stop my hands being black, because the graphite in the cast iron will turn your hands black. Some people might ask, well, why are you going to take off, just clean it up and then clean it up and then come back and do a finishing pass? And the reason for it is that because of the casting process, when the cast iron cools, the skin does first of all, and then the inside does. So if you can imagine the molten metal on the inside contracting, it's going to try and be pulling this skin. And so partly that's where the shrinkage comes from, but you've got a lot of stress in a casting now. There's a story about a certain luxury car maker who used to cast their engine blocks and then put them out the back in a paddock for, a decade or so, just to let the stresses equalise. And I have heard of that being done, and there are modern processes to stress relieve castings as well. But what I want to do here is take off, do a minimum cleanup on all the three faces, and then come back, and once the casting has had a chance to just sort of, work out where it is, come back and take it down to something close to size. The alternative is, of course, you spend all this time getting this face beautifully flat and smooth, and then you do the next face, and because you remove material here and you haven't removed material there, it might twist a little bit on you. Probably wouldn't. Simple casting like this, it probably wouldn't, but it's one of those things. It's good practice to do. I've now cleaned up one face, and that's basically going to be my datum face. I'm now using a protractor to do this, and then to do this face, and then repeat with, I think it's a 60 degree or 45 degree angle. I'll check in a moment. On this face. Once again, we're just aiming for clean up so we can see where we are. You can see there's a bit knocked off the corner there, so we'll come back to that when we do our finishing cuts. But really, this is the simple, the condensed version of how it all works is basically using a protractor and putting your angle on. Do that. Don't worry about this being exact. I mean, the better you can get this, the easier things will be later on. But we're also going to do a bit of match machining to make sure that the angles are the same on each one of them. I'm now going back for a second cut. What I've done is I've gone around and I've measured all around there, and I mean, some of that is due to the pattern and the casting and all that sort of thing, but I've chosen my thinnest section on both sides, and then I've gone along and said, right, I'll take off a minimal amount from there, and I've also gone along and marked the shall we say, the non-square side. So now that I'm doing my finishing cuts, I want to take them all from the same side so they're all square. So this is the non-square side with the blue. So that will go up against my angle plate, my fixed angle plate. I'm going to take a very small cut on this side. On this side I'm taking off 2, on this side I'm taking off 1.5, and that should get rid of that, or at least most of it, and go from there. Unfortunately, it does look like I have a flaw in this casting, a bit of a void, and it's a pity, but that's all right. I don't think it'll affect anything, because the plan with this is to tap holes on there for hold down clamps and all that sort of thing. So I might be tapping into a void, or I might have to avoid a void. I've just finished the finish cut on my first block, and the way I did that was that I machined one face, and arbitrarily I chose one with the thinnest wall just to give myself a clean-up cut, and then I positioned that in my between my angle blocks, setting it like so, with a wrong way around, with a protractor. One thing, just check your protractor. I discovered that on this one the housing comes out slightly over the rule, and so I think I've introduced a small error there because I was up on that rather than on the blade, so just watch that one. When cutting cast iron, particularly where you're cutting a sharp edge like this, remember cast iron is strong in compression and weak in tension, and so what you've got to watch for is when you're running your cutter in, run the cutter into the work. If you run it out of the work, you'll tend to get it chipping and spalling on the edge. If you run it into the work, you'll get a much smoother edge. Now, I'm going to take a bit more off these edges, but I want to leave them relatively sharp for the moment, just so that I've got references. What I have to do now is get the other block, which is this one, down to the same size, and as you can see there's a bit of material to come off there. It's actually going to come off like that, so it's probably going to be closer to 2 and 2 millimeters or something like that. Before, when I had one block machine and one knot, or sorry, one block finish machine and one block knot, when I put them like this I had about a 3 millimeter gap there and a 3 millimeter gap there. So on the block I hadn't machined, I've now taken that 3 millimeters off. In fact, a little bit more. I think I took off 3.5, and I've got just a little bit to take off here. So I need to take off 2 just here, which would be nice because it'll clean up the porosity in the casting. So I've machined both blocks down to finish size. I've checked the angles on this with a slightly better protractor, and this one I'll read to 5 minutes. This one seems to be within about 5 minutes, which, considering it's going to be used for machining and that sort of thing, fine by me. This one's out a little bit. Now, the way I'm going to get these to match up, I mean, I can line that up there, and there's just a slight mismatch there, and there's a slight mismatch there. All right. So I've got a slight mismatch in my angles. So I'm going to take the one which I'm calling good, and I'm going to put that one on top. Now I'll have to jack the back corner up so I don't take that off. But what that means, because if this angle and this angle are equal, these two surfaces are parallel, and so I can put a skim on that and just take that down to where I want it, or get it parallel to that. I could turn these this way and do that way as well, if those were out, using the same principles. Sandwich those with my angle plates just to make sure they don't move. But that's how you get them matching angles. Now, if you wanted to be really, should we say, pedantic about this, and get better accuracy than I can get with that protractor, you could put a sign block on there, and then run your for whatever angle it is, run an indicator along, and then use shims to just lift that ever so slightly until you get that flat. Okay, then you know that angle is exactly whatever it is with respect to the mill travel, and so when you put that one on there, you can once again take a skim and you can get that back down. Then you flip it over, leaving the shim out this time because this angle is now spot on. Flip those over and repeat, and so you can get them very exact if you want them to. For me, I don't need that sort of accuracy. These are going to be used for example, putting a gib strip on. So just to finish off, this is my setup for machining the faces parallel. I've got these clamped here. I've got a parallel between, so I've got some clearance for the milling cutter. I've got some bits of card here to allow for the slight variation in the size of the thickness of the casting. So basically I found my low point and I just sort of set it at 0 and then just came across, and it's just cleaned up. Before doing this, the difference between here and here was something like 0.2, 0.25 of a millimetre, so it wasn't terribly much, but just enough to get these two angles parallel. It took it a while to work out which face to take this off, because it involved a lot of turning the castings around just to see what matched best and which face was the odd one out, and it turned out that it was this one here. So that's how that was done. So thanks for watching, and I hope this has been of interest. This will be it for this video, and in a future video I'll probably you'll probably see these with a few holes and things in them being used for fixtures.